Hello everyone, welcome. It is your third chapter, Distributed Computing Paradigms. The next paradigm is the mobile agent paradigm. The mobile agent is a transportable program or object. In this paradigm, an agent is launched from an originating host. The agent then travels autonomously from host to host according to an itinerary that it carries, that means in a moving basis. Okay, at each stop the agent accesses the necessary resources or services and performs the necessary task to accomplish its mission. So here the mobile agent is a transportable program, that means agent transports host to host and it accomplishes its task. Okay, so here the figure shows the mobile agent paradigm. See here there are host 1, 2, 3 and 4. So host 1 is holding the agent and the agent accesses the required resources of host 1 and it will accomplish its task at host 1, and next it will be transported to host 2 and there it will access the resources of host 2 to accomplish its task, and it will move to host 3 and host 4. Okay, so here this is mobile agent paradigm, that is agent is moving from host to host. So next one is the network services paradigm. In this paradigm, service providers register themselves with a directory server on a network. A process desiring a particular service contacts the directory server at runtime, and if service is available, the process will be provided a reference to the server. Using the reference, the process interacts with the service. Okay, so here in this paradigm, the service providers register themselves with the directory servers. Okay, the service requester will access the directory server, and if the service is available, then the requester will get one reference to that service. So using this reference, the requester will access the service. So this paradigm offers an extra abstraction, that is the location transparency. Location transparency allows a software developer to access an object or a service without having to be cognizant of the location of the object or service. That means here the developer will not come to know exactly where the object is located. Okay, the location of object, that is location transparency. So here the figure shows the network services paradigm. See here the service requester contacts the directory services for any required service. So if service is available, the requester is provided with the reference, okay, the reference to that service. So using that reference, the service requester will contact the service object, or service requester will access the service. The next one is the collaborative application paradigm, or a groupware. In this paradigm, processes participate in a collaborative session as a group. Each participating processes may contribute input to part or all of the group. Processes may do so using multicasting to send data to all or part of the group, or they may use virtual sketchpads or whiteboards which allow each participant to read and write data to a shared display. So in this paradigm, processes participate in a collaborative session or a cooperative session as a group. So here there is a group and the data will be sent to a part of the group or to the entire group members using a technique called multicasting. Okay, or they may use virtual sketchpads or whiteboards which allow each participant to read and write data to a shared display. So this whiteboard or a virtual sketchpad is shared among the participants of the group, and the participants can write data to the shared display or read data from shared display. So here the collaborative applications paradigm. First one is message based groupware paradigm. See here messages are sent to all the participants or the part of the group using a technique called multicasting. And next one is whiteboard based groupware paradigm. Here the whiteboard is, the virtual whiteboard is shared among the participants. So the participants can write data to the whiteboard or read data from the whiteboard. So the next one is trade-off. Each advantage is offset by some disadvantage. That means if you want get any advantage, it will be at a price of a disadvantage. Okay, so here first one is level of abstraction versus overhead. At the lowest level are the most basic paradigms, message passing and client server. At the highest level of are object spaces and collaborative computing, which provide the most abstraction. The development of highly complex application may be greatly aided by a tool that offers a high level of abstraction, but abstraction comes at a price overhead. See here at the lowest level we have message passing and client server. So they offer a lowest level of abstraction. That means the code is written for these application will be not highly complex, but here the highest level of paradigms are object spaces and collaborative. They offer the highest level of abstraction. So for supporting highest level of abstraction, we need to add more complex codes in that application. So the abstraction comes at a price overhead. So these more complex programs will be a overhead. Okay, the complex program will be a overhead. Why? Because such programs or such applications will require more executing time or more resources or memory space. Okay, so abstraction comes at a price overhead. So next one is scalability. The complexity of distributed application increases as number of participants increases. Using message passing, the developer must provide the coding to manage the addresses to contact the participants individually. The complexity grows as the number of participants increases. So here in the message passing paradigm, the complexity grows as the number of participants increases. With a toolkit based on a high level paradigm such as object spaces or publish subscribe message system, the complexity of managing the participants is handled by the system and not by the program. Okay, an application thus implemented can support an increase in the number of participants with no additional complexity. Okay, so you can add any number of participants to these paradigms like object spaces or publish subscribe message system. Okay, so one more is a mobile agent is another paradigm that allows an application to scale well. That means you can add any number of participants to mobile agent paradigm and without incurring any complexity. Okay, since the number of participants can increase without any significant impact on the complexity of a program based on the paradigm. So here as you increase the number of participants, the complexity of program will not increase. Okay, so here next one is cross-platform support. A tool that supports heterogeneous platforms necessarily incurs complexity compared to one that supports a single platform. For the same reason, the programming syntax becomes more cumbersome. So the tool that supports heterogeneous platforms, that means different types of platforms, they necessarily incur complexity compared to a that supports single platform. Okay, because programming syntax becomes more complex or cumbersome. So here many Java technologies run on Java virtual machines only, and COM and DCOM, that is component object model technologies, are deployable on Microsoft platforms only. So Java and COM and DCOM, they are not platform independent, that means they are platform dependent. Okay, they do not support heterogeneous platforms. That means Java programs can run only on Java virtual machines, and COM and DCOM they will run only on Microsoft platforms. So there is one more architecture, that is CORBA. common object request broker architecture is designed for cross-platform support, hence it supports programs written in different languages. So this Corba architecture supports heterogeneous platforms. That means the programs written in any language can be executed or can run on Corba architecture.